The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everyone. Trying to show my screen. It's not cooperating.
Oh, we can see your screen.
Oh, you can see my screen? Okay. Well, no wonder it's not cooperating. I'm trying to do something it's already doing. Okay. Welcome to We Speak Linux. We're here to teach Windows admin and developers more about Linux. And we're going to do this through presentations and blog posts and peer support. I'm trying to grow a community of Windows admins and Linux developers ready to transition to Linux, as there's a lot of stuff that's transitioning from the Microsoft realm into Linux, and most of us only know Windows. Kind of slide deck won't. There we go. So as part of our community, you can subscribe to our newsletter on our homepage. You can also join our Slack community from our homepage and follow us on Twitter. We have a YouTube channel where we will upload this video afterwards. That way, if you want to go back and review it, you can. And we have our previous videos there as well. We meet on the first Thursday of each month at 12 noon Eastern Time. Next month, on August the 2nd, we'll have DevOps with Kubernetes and Helm with Jessica Dean. And then we will have Bob Ward doing something on Linux the following month. That's the end of my slide deck. And we will turn it over to Argenis to tell us all about containers on Linux and SQL, my favorite topic.
Awesome. Thank you, Tracy. Thank you so much. So good morning, everybody. I know Tracy said it's afternoon, but it's very much morning here in Redmond, Washington. It is sunny and it is beautiful, and I don't know why I'm indoors delivering a presentation to you guys, but I'm actually kidding. It's my pleasure to be here delivering a presentation to you guys on SQL Server, on Docker containers, on Linux. And the thing that I want to make sure that everyone understands in this call, and I know there's about 20 plus some of you only, but I want to make sure that everyone gets this. This is an introductory kind of presentation, a 101 kind of presentation, a level 100 kind of a presentation. Don't expect me to go in depth on any topic as we chat on SQL Server and Docker containers on Linux. Let me tell you guys a little bit about me. My name is Argenis Fernandez, and I am a principal program manager on the Microsoft Database Systems team. More specifically, I work with SQL Server on premises. I do a little bit of work with Azure as well. I am a part of the Azure data organization. We all are here. All every one of the SQL Server Tiger team and every one of the Microsoft Database Systems team is actually part of the Azure data organization. I did a lot of VMware throughout my career. I still do a lot of VMware these days. I'm a V expert. I was a V expert. I don't know if that actually still applies to me after I joined Microsoft again this year or earlier on this year. I've been an MVP. I was an MVP for a few years, and I also sat on the board of directors for PASS for a year or so. And if you guys ever heard of the Microsoft Certified Master Certification, I was part of the limited amount of folks that got a chance of getting that certification from Microsoft. That certification is now no longer offered. I did found the I founded the security virtual chapter for PASS way back when, I want to say 2013 as well, along with Robert Davis, rest in peace, SQL Soldier, if you met him, one of the most kind souls I've ever met, and somebody who would give selflessly back to the community, and that's something that I myself love to do. I love to give back to the community as much as I possibly can. Even though my calendar and my set of tasks is quite insane these days, I always make the time to get back to the community out there. And you guys on the line that are, Windows administrators trying to transition to Linux, I wouldn't call it a transition. Okay, I know Tracy used the word transition, but I don't see us like completely transferring to Linux. It's not like we're shifting and lifting over some to Linux. I definitely see us working on a hybrid kind of a model for a fair amount of time. You know, what's going to happen after that, really, no one knows. Right? But I definitely see SQL Server running on multiple platforms, including Linux, including containers, and Windows for the longest time. And then you should only see our support statements or our life cycle around support for SQL Server. Right? We have an extensive supportability plan for SQL Server as well. So let's go over the agenda today. I'm going to keep this again very low, very high level. We're not going to go into the guts of pretty much anything here. So we're going to chat about the basics. We're going to see. We want to talk a little bit about what containers, what they are, and why they are kind of taking the industry by storm. Even though they've been around for a while, the containers are something that in the scheme of computing, they have gained relevance extremely quickly. And you may have seen this today on the more on the application side of the house. Right? You may have seen folks talking about containers more on to host apps rather than databases. But here we're going to chat a little bit about why you would run a database on a container. What is so enticing about a container that actually makes it interesting for you to run a very sticky or persistent workload like a database inside a container? Why would you want to do that? So we'll chat a little bit about that. Then we'll see how do I get started with SQL Server and Docker containers on Linux. Okay, I have a VM that I just created in Azure recently, and then we will take that VM that's running Linux, and we will go ahead and install Docker, and we will get a SQL Server running on a container on that VM. And you guys will we will go over the commands that we're going to use to achieve that. And then we will talk about a little bit about Windows and a little bit about Mac, because it's not all Linux again, right? Linux is a big push for us. Docker containers is definitely one of the most interesting plays for us in SQL Server overall. But I don't want you guys to think that we haven't thought about containers on Windows. We have, and containers on Mac we have as well. So we will chat about those two at the end, and then I'll give you my contact information at the end. One thing that I do want to make sure, guys, is that if you have questions, bring them up as they come to your head. So feel free to interrupt. Tracy will be reading your questions as you present them, and we will take care of them as soon as possible. It's important that you guys keep the context relevant, because if we save the good questions for the end, then we'll really miss out on context here. And context is very important when talking about containers. So anyway, what is a container? A container is basically a unit of work in a computer. You can think of a container largely is at a very, very, very high level. You can think of a container as just an application that's running on your system. Okay, a container is a runtime, a set of libraries, and then everything that you need to run that application or to run that one unit of work is contained within the same within a single entity. So there is not a notion of a container that has multiple parts to it. A container is that one piece that you load, run, execute, and then you do things with it. Okay, you execute commands inside of the container, or maybe if you want to venture and install things inside of a container, you could do so. But it's a very different concept. Okay, one of the things that you used to do in the past with VMs, you would first get the actual host for the VM provisioned. You would get the operating system installed on top of that host. And then a hypervisor will be the thing that you will be running there. And then you will create your VMs on top of that. And at some point, you will just create your, actually, I'm going to use this. This is actually very good to explain this. And let me just switch to this this particular slide. You can see that two different architectures here. On your left, you have how VMs would operate, and on your right, you will see how containers operate. You would have your infrastructure at the bottom, right? So your physical hosts. Then on VMs, you would have a hypervisor. Okay, so this will be this right here. Then you would have your different VMs, and on each VM, you would install a guest OS. You can see that here. You will have your binaries and your libraries here for every VM. And then you would have, potentially SQL Server processes here running inside of your VM with other applications. In the cases of containers, things look a lot more like this. And you have your underlying infrastructure, your host operating system. Then you would have, in this case, we want to talk about Docker, okay, which is the container runtime that we use for SQL Server in general. We do not advertise any other container runtimes, but they may or may not work. We're definitely supporting Docker. But one thing that's important is that we run SQL Server anywhere where Docker is supported. Okay, so that tells you that Docker runs on a variety of platforms and a variety of different processor architectures. And that means that you can run SQL Server anywhere Docker is supported, as long as the architecture is supported for SQL Server. And we can go in depth in that in a little bit. But largely, I wanted you guys to see the big difference here on the container side. There is no guest OS on a container whatsoever. And that means that there is significant improvements in the amount of not only storage footprint, right? Naturally, you can already picture that since there is no need for a guest OS to run on a container, the container themselves are going to be significantly smaller than a VM, so a lot more lightweight. There is also going to be a significant amount of savings in the form of CPU consumption and memory footprint, because you're not going to have all of these things running at the operating system level within your VM. There is no that wouldn't apply to a container. And so imagine on a VM you can have your Windows Server 2016, and most of you guys don't use Windows Server Core, so you end up with a lot of different things that Windows Server GUI actually installs. So if you even look at the out of the box, Windows Server 2016 will even install some Xbox related services, right? Because the shell that Windows Server 2016 uses is exactly the same as Windows 10. So there's a lot of things that should not be on a server when you install Windows Server 2016 GUI based. This is actually one of the reasons. That's one of the main reasons why I advocate for Windows Server Core. But the reality is that very few of you actually leverage Windows Server Core, and you just go install full-blown Windows Server, and then you just deal with it, right? But the reality is that creates a set of challenges, from the patching point of view, and it also creates, it also affects the performance of your VMs, because now you're actually running operating system processes and more things than you actually need. So in the case of a container, there is no operating system within a container whatsoever. So there is no need to perform any context switches between in-container processes. There's only one container process that's running. You can run other things on a container, but it makes it extremely lightweight. And so you can build your own containers, right? We can provide you with the base layers of your actual container, and then create things on top of a container. Containers have this wonderful concept of layering. And so rather than rolling out a VM and install software on top of it, you will just deploy a container and that's it. Right? That container, you previously installed everything you needed on it, or created a new container image that had all the things that you needed. So this is a great way, for example, in DevOps environments, you can create your container that actually leverages, that has all your database schema and code already rolled out within the container itself. Just roll out that container, and off it goes. So you wouldn't need to install any software on it after the fact. It's kind of like having a template of a VM already in that sense. You just roll that out, and it just works right off the bat. So the deployment, you can imagine that deploying these things is pretty seamless. And there's significantly less downtime on a container than there will be on a VM. So imagine all the things that have to happen. Forget about containers, forget about VMs. You guys know how long it takes to reboot a physical server. Right? It takes potentially, I'm not kidding, on a server with multiple terabytes of RAM, it could take an hour. And for that server to come online after it performs all the tests on memory, et cetera, et cetera, et cetera. So that's huge downtime, right? Especially for a very big box, like a Superdome, for example. That could take a significant amount of time to restart. We're talking 30 minutes in some cases. And on the case of a VM, that's actually one of the reasons why you would go VM. If you needed to restart your machine, your virtual machine, you're not going to wait for any physical hardware for that operation to take place. So naturally, you just restart your VM, and your operating system starts loading right away without waiting for any hardware. But you're still loading an operating system. You may potentially have to go through patching of that operating system. You know how sometimes Windows starts applying patches when it starts. Well, on a VM, that could very well happen, right? As the VM actually starts, you may experience some downtime while Windows actually loads up all of its patches, et cetera. And then eventually, it's going to kick off the SQL Server service. And then at that point, once we perform, recovery of the databases involved, et cetera, is when we will allow connections to take place against that database or set of databases. In the case of a container, think about this for a second. This is just a process that's running on a host, right? It can kill a container really quickly and restart it, and it will be a seconds operation, right? Potentially a very little time. You'll see, just a couple seconds to get that container back up and running again. Naturally, running recovery on the databases, and these are things that may potentially take a while because all of you guys understand that SQL Server has to run recovery on all of its databases to bring them online in a transactionally consistent fashion. And this process of recovery not only entails, going over the transaction log and, performing redo of any transactions that need to be rolled forward or undo of any transactions that need to be rolled back, but it also entails doing things like creating in-memory OLTP tables, right? Loading data for those in-memory OLTP tables right at startup time, and that startup time is actually part of your downtime. But you can imagine that on the container story, we have shaved off a significant amount of time of downtime from the fact that we don't have an underlying operating system. And so that makes it really interesting from an availability point of view. Now, I would say that yes, in the past, containers were considered ephemeral, meaning you would basically just get rid of them and consider it very unstable, and you didn't really care if something died, and you would just respawn it, it will be fine, which will be the case on like a web server, for example. If you kicked off a bunch of containers running Nginx, for example, and all of a sudden a few containers died, who cares, right? And you just restart it and off you go. In the case of a database, you don't want to be in that situation, right? Because the database is being one of the most important pieces of infrastructure that need to be kept online as long as possible, for as long as possible. That ephemeral story right there collides with the very nature of databases. So the question that you would ask yourself is, and this is actually the slide that I created for the beginning of this section, how they call this section is, why would I want to run SQL Server on containers? But I think I mentioned already a few things that are right off the bat should be resonating with you. Okay? The fact that this is, they're so fast, they have very little CPU memory footprint requirements for the containers themselves. It's a very lean way of running SQL Server. This actually helps you with your licensing place as well, right? I mean, yes, I work for Microsoft and I understand we make money off of licensing, but there is no operating system licensing on a container. So that should tell you that there's a potential for saving some money off of containers, of running SQL Server on containers, right? But not just that. I mean, restarting SQL Server on a container, again, it's extremely fast. And the fact that we run anywhere Docker is supported, that actually answers the question the questions that I had for my last part of the presentation, which is, what about Windows or what about Mac? We'll go in detail on those in a second.
One question for you. Any plans with
Yes.
Docker Swarm official support?
So I don't think we're going to be supporting Docker Swarm officially. There are Kubernetes support is definitely there. Docker Swarm, it's still an open-ended question for us. So the question is, if you guys haven't heard what Docker Swarm is, it's basically an orchestration layer for Kubernetes. So we're definitely in the Kubernetes space, and we support OpenShift as well. I'm not aware of our official statement of support on Docker Swarm. So I will, how about this? I'll follow up on that, and I'll make sure that we get, that question completely answered. But definitely in the Kubernetes space, and definitely on OpenShift. But Docker Swarm support cannot quite answer at this time. So, but I'll get back to you on that. Hopefully, I can get you a better answer than a maybe right now. Any other questions?
Just a comment was Swarm does fit better with smaller companies.
But Swarm is actually more does better with smaller companies. Was that the comment? Okay, well, feedback taken. I will follow up on this. I have a teammate that is actually the PM for SQL Server on containers, and he should be able to answer that question and provide a statement in that regard. I don't see why it wouldn't run. I don't know whether we actually support it or not. So let me move on, and then I'll make a note of this, and then we can take it from there. Any other questions on that?
No.
Okay,
That's
cool.
it.
Thank you. Awesome. So I think it's better seen than on a PowerPoint, right? So how about we actually move on to demos. Oh, by the way, what's something that's really important that we definitely want to talk about? Containers are not just about the containers themselves. Okay, databases on containers are all about this, which is the persistent storage, where you're going to be saving your databases. Containers you stop, you remove, you upgrade, etc. But the data that you want for your databases, the one that you want to persist, that has to go into what's called persistent storage. The data that you want to keep or withstand failures or of the containers themselves, that data should not live within the container itself. Because the moment you remove a container, whatever data you have written to that container disappears. However, there is the concept of persistent storage for containers that you must absolutely understand, where you have storage that is not within the container, right? It's outside of it. Could be living on shared storage, like a storage array. Could be living on, just a different file system than the one your container actually has access to. It could be living somewhere else, right? It could be a filer on your network, etc. It could be just some other storage device that is persisted on your machine, so that your databases will be placed in there as opposed to living within the container itself, within the storage or the file system for the container itself. You want to do it that way in most cases. There will be some cases where you will create your own containers and place your data within the containers themselves, because you will want that data to be ephemeral, meaning you will want to get rid of container and data at the same time, so that when you reload the container, maybe you will load a new version of the data itself. Okay, so that's something that's very important for everyone to understand here. It's not like you're always going to lose the data that you place in the containers. If you place the data within the container itself, you will lose it. But if you use persistent storage, you can definitely keep that that data around long after your container has disappeared. And that actually enables a very simple upgrade path, which is delete, remove the container that you had for a previous version of SQL Server, a previous build, launch a new container, point it to the persistent storage that you had before, and off you go. And things will just work. Now your databases were sitting in that persistent storage, so now your databases can be seen by the new container that's running the newer build of SQL Server. And naturally, that container can use that database and serve the database directly.
Okay. One more question came in. Can you use Kubernetes for container failover?
So container failover in Kubernetes is not supported today. It's something that we're definitely looking at. We don't have support for this right now.
Okay. Any plans for Windows container support in production?
That is actually, I'll save that for the very end of the presentation. But yes, we should be able to support containers on Windows. So yes, we'll talk a little bit more detail on that when we get to the Mac and Windows and Mac section. Any other questions there?
Nope, that's it.
Okay. All right. So I think at this point I want to give you a little demo. So how do I get started with SQL Server and Docker containers on Linux? So let's chat about the things that you should do to kind of go start your journey with SQL on Docker containers. And for that, I'm actually going to switch out of the presentation to discard my annotations. And hopefully everyone can see my screen right now, correct?
Yes.
Okay, cool. So I did create a VM earlier on today. This is the name of it. It's Argenis Docker Host 3. And this is a VM that I created in Azure. There's nothing fancy about it other than it runs Ubuntu 16.04. And yes, I know that you guys may be wondering, hey, wait a second, 16.04 is not the latest version of Ubuntu. What's up with that? I just created it with 16.04. It works on 19.04 just the same. And I will show you that in a minute. But basically, the things that you will want to do is, so number one, let's go over these really quick. This is the install guide for Docker CE on Ubuntu. Okay. Like I said before, anything that Ubuntu supports, we will support as long as the architecture matches. And for that, I have, where's the Docker platform? Okay, so here we go. For the community edition, right, Docker supports, so let me take a step back, and I'm sorry about this. Docker has two editions. The community edition, which is free, and you do not have to pay licensing for this. You can, just download it, use it. It's freely available. It's available for Mac. It's available for Windows. It's available for CentOS, Debian, Fedora, Ubuntu, and on infrastructure as a service clouds, there's Docker CE for Azure and even Docker CE for AWS. Okay, so that's for the community edition. For the enterprise edition, you have support for Red Hat, Enterprise Linux, SUSE, and other platforms. You can actually see them here. All the supported platforms where you can install Docker EE. So These are the actual processor architectures right here. So x86-64, AMD64, so your Intel processors, IBM Power and IBM Z. Obviously, we don't run in this space, okay? So Docker Enterprise Edition does not, we cannot run SQL Server on any of these right here, but definitely on any of the SQL Server on Linux, and any of the Docker on Linux implementations. On Windows Server, again, when we get to Windows, we'll answer that question, but just be clear that on Windows Server, we only support SQL Server Developer Edition. Okay, so our support for SQL Server on Windows containers is limited right now. And there's also, eventually we would like to support Linux containers on Windows as well. So that's, you wouldn't have to have a Linux machine running underneath the hood as your host. Your host can be a Windows machine, but that's also in the plans. Okay, that's not something that we have made a statement or provided any time frames for that yet. So you can see all the flavors of Linux that we support. It says Ubuntu, but it doesn't say which version of Ubuntu it actually supports. As a matter of fact, I have this VM right here. So if you take a look here at what the actual release of Linux on that VM is, that's Ubuntu 18.04. Right? And if you actually look at what I'm actually running here, I have my SQL Server. I have my SQL Server container, latest version of SQL Server 2017 on Linux, running on Ubuntu 18.04. This is a little bit different than what SQL Server on Linux supports right now. SQL Server on Linux, not SQL Server on Docker containers on Linux. SQL Server on Linux is only supported on Ubuntu 16.04 right now. Okay, yes, you can imagine that we're looking into supporting newer versions of Ubuntu, but we haven't made a statement on when that's going to come yet. Right, so that's something that's actually being looked at right now. So I already gave you a little bit of a preview, and the fact that Docker commands typically have to be prefaced by running Docker. But here I'm gonna start with this. This is the Argenis Docker Host 3 VM machine that I created today for the purposes of this presentation. So we're going to go ahead and perform a full-blown install of Docker, and then we'll go ahead and install SQL Server on Linux and pull a SQL Server on Linux container, and we will run it here as well. So for that, we basically want to use the Docker CE for Ubuntu install guide. And so one of the things that you can see here that all the versions that are supported for Ubuntu. Definitely 64-bit. We will not support 32-bit SQL Server. Remember, we haven't supported SQL Server 32-bit for the longest time. Something that's important is that there have been previous versions of Docker that you may have on your machine. If you had any of those need to be removed. Okay, so the original Docker-engine or Docker.io, any of those versions need to be removed. So just make sure that you get rid of them as you actually deploy your Docker machine or your Docker host. Okay, so I just got rid of those. There was nothing installed, but just for the sake of completion, I wanted to show that statement. This is the brand new VM. The next thing that you do is set up the repository, right? And the way that you set up the repository is at first you actually run apt-get update, and apt-get, you guys will very well know, it's a package manager. We just want to update the list of packages available. That's going to take just a few seconds. And yeah, since it's running on Azure, it's actually looking at the Azure set of packages, and we have a local copy of the packages in Azure to make things a lot faster. So the next thing to do is install the packages to allow apt to use a repository over HTTPS. This is something that Docker requires, and so I just copied this command right here. We'll paste it. So these are all the packages that we're going to have to install, right? apt transport HTTPS, steer certificates, curl is the other one, and then software properties coming. So once we get that done, go ahead and paste this here. By the way, I use Mobile Xterm, which is an extremely flexible terminal for Windows. You don't have to use this. There is something that's very interesting that Microsoft has provided there, and that is the Windows subsystem for Linux. And if you haven't looked into this, you may want to look for this, right? So it's funny, this user group is called We Speak Linux, WSL, and this is Windows Subsystem for Linux, WSL. And this is actually the acronym that we use. So Windows Subsystem for Linux allows you to go to the Microsoft Store, okay, basically our application store, and then here you go, download your Linux distribution of choice. And so I have one of those installed on my machine, so I can click here and say Ubuntu, and there is my Ubuntu running on the Windows subsystem for Linux running on my machine. And as you can imagine, I can install the SSH packages and do SSH directly from here. Okay, so I don't have to buy Mobile Xterm, although Mobile Xterm does have a free offering as well. If you like, Mobile Xterm has pretty nice capabilities, like the way that it handles copy and paste is particularly useful. It also does things like managing sessions. It switches directories as you switch directories on your terminal, et cetera, et cetera. So there's a few things that are quite nice. You can multi-exec. So if you're working with multiple sessions at the same time, you can send the same command to all the terminals at the same time. So it's got some nice functionality, but it's just a personal preference, right? You do not have to use Mobile Xterm by any means. Do I want to continue installing those packages? I say yes, and that's only going to take a few seconds until it's just finished. So now that we have those base packages that we need installed, we're going to go ahead and download and add the official GPG key for Docker to our system. And the way that we do that is by running that command. I'm just going to copy and paste it. Takes a second. Now you should verify, for security's sake, that the fingerprint, that you have the key with this particular hex fingerprint. So we're going to search for it. And here we go. This actually matches this. If you get that number correct, if you get that string correct, that key, you got it matches, then you're good. You're good. So the next thing is to make sure that we want to use the stable repository. Okay. The way that you do that is by running this command. This is a stable repository for Ubuntu. You may want to use the other repositories for Ubuntu to see if we actually have, if you're ever planning to test new versions of Docker before they actually get rolled out and see if there's anything breaks. You're welcome to test them. We do not support test versions of Ubuntu though. We only support the stable. Stable branches of Docker, not Ubuntu. And so once we do that, we added the stable repository for Docker on Ubuntu. Now we go ahead and paste this command, which actually is just an apt-get update, which will again refresh the set of packages that we have available on our machine. And that only takes a second as well. And now is when we can finally install the latest version of Docker CE. If you want to test other versions, there's other ways of installing them, and they're listed in this document as well. So we paste this command. This is going to install Docker CE. It's going to ask if we want to install all 128 megabytes worth of stuff. We say yes, and this is extremely fast. I will say this, the actual provisioning of your physical hosts, or maybe even your VMs, if you decide to run Docker on top of VMs in your data center, should be extremely simple and extremely straightforward. Setting this up in an automated fashion will be very simple, and it wouldn't take a lot of time for you to script out a full deploy of a Docker for a new host in your infrastructure. Okay, so that way you can get up and running in containers in very little time. Okay, so that said, here's instructions on how to upgrade Docker if you need to upgrade Docker at a later time. But right now, my intention was only to show you guys how Docker gets installed. And then at that point, once we have done that, that fast apt-get install Docker CE, we're ready to start running, to start installing SQL Server on Docker containers on Linux. So for that, we go to this page right now. It shows you how to run the SQL Server container image with Docker. This is very, very, very straightforward. So you can see the prerequisites there, right? There is a minimum of 2 GB of RAM required. Okay, so I want to make that perfectly clear. Even though we may take a little bit less than 2 GB to actually kickstart the system, we do require a minimum of 2 GB of RAM to get the system going, and a minimum of 2 GB of disk space as well. So to pull and run the container image, this is really all you have to do. You copy this command right here, okay? Docker pull Microsoft SQL Server server-linux column 2017-latest. And that's actually going to pull from our Docker repository, okay, from the public Docker repository. Notice that there's nowhere do I have to pass a license, or nowhere do I have to say anything to just get this going, okay? You can see that we support tags for the different for different versions of SQL Server to install, for different builds of SQL Server to install. So here you see how we have 2017 GA, and we also have GDR releases that only have security releases for SQL Server 2017, and then we have all the CUs, okay? But if you always pick to the 2017 latest, that will just go ahead and install the latest version of SQL Server 2017. If you just say latest, then whatever's our latest GA release, imagine that we have released, I don't know, SQL Server 2035, and at that point, if you say latest, then you would get 2035, okay? So this is how we're gonna go about installing SQL Server, or getting a SQL Server container deployed here to this machine. So just Docker pull Microsoft SQL Server Linux 2017 latest. And to give you an idea of the level of acceptance that this has had with our with the community out there, with our customers out there, we have had to date more than 6 million pulls of SQL Server on Docker containers on Linux, which is an amazing number if you consider that this was released very recently. Okay, so one thing that's when I want to run tons of containers, I can do that as well. And then the actual sharing of the resources in the machines are handled by Docker itself. Okay, much in the sense that a hypervisor manages the sharing of the resources across VMs, and in containers, you have Docker managing the resources, or the sharing of the resources across the different containers that are running on the same machine. Okay. Now, with that done, we're going to go ahead and see what it would actually take for us to run SQL Server and get it up and running. And now that we have the image downloaded and it's already cached in my system, I can just Docker run SQL Server. Right? I indicate which image I actually want to kick off this container out of. And very important, these are things that are mandatory for us. Okay, we always request that you pass, that you accept the terms and conditions for running SQL Server. So yes, we force you to pass and accept all environment variable to the VM. We gotta keep our lawyers happy. Sorry. And this is how you would specify an SAE password for your container. And was there a question there, Tracy?
I was going to ask you a quick question. Yeah. Can you use Windows authentication for SQL and Docker?
Not yet. So that's something that we're looking into as well.
That was it.
I will. You know what? There may be a way to do it, but I'm not familiar with it yet. So let me get back to you on that. Let me get back to you on that because I believe there is a way to do it, but I haven't done it myself.
Okay.
So let's stick to SQL authentication for now, and then I'll answer that question offline for folks on the line. This is then how you run your container based off that image. So these are environment variables that you're passing down to the container, and this is a port mapping that you're specifying. And this may sound a little strange, but here's what's happening. Okay, you can have multiple instances of SQL Server, to say multiple containers from SQL Server, running on multiple ports on your machine. Right? So rather than just one SQL Server that may be running on port 1433, that's the port that it actually runs by default on the container itself. If you want to serve SQL Server on a different port, you would actually specify what's the local port that for the host itself that it's actually going to be forwarded to the container's port. So your container listens on 1433. Your host itself may offer to listen SQL Server on a different port. So you don't have to run SQL Server on 1433 if you don't want to. I will say though that this is our traditional recommendation is to just run SQL Server on 1433 unless you have some compliance or security reasons to do so. And this is how you specify a name for the container. The name has to be unique across all the containers that are running on your machine. Okay, so this is very important. If you can definitely you can pass random names here. You don't have to map them to DNS or anything like that. Okay, so these are just names within Docker itself that to identify the containers as they run within the machine itself. Okay. So this is, let's paste that statement. But if you look at this for a second, you may be wondering, hey, wait, doesn't Linux save history for like every command that I run? The answer to that is yes, it does. Okay, so if instead of doing this, you don't want to you don't want to save this command in history, if your system is configured by default by passing by putting space before the actual command itself, so space, and then the command itself. Now I'm going to paste it. Oops. Let me just copy that again. So I have a space first, then I paste it. If I hit enter, then this command should not be recorded in history. So if I go up, this actually saved the first command that I pasted, but the second one did not save. Okay, so it's unfortunate that this demo didn't work out exactly the way I wanted. But imagine that you want to do some command that's sensitive. If you notice, if I go up, let me try that again. So clear. Some command that is sensitive, meaning has a password or something. If I type that, if I go up, hit arrow up, you can see that the history will save to the command. But if I do this, put a space at the beginning and then say some command that is also sensitive, hit enter, that command is not saved in history. So notice how I go back to the original one. That's when I press arrow up, it says some command that is sensitive, but not the one that was also sensitive. Okay, so that's a little tip for you guys on how to run commands without saving sensitive information in the history. Okay, so this is just a good security practice on Linux boxes. This may not work in your system, however, it works out of the box on Ubuntu. Okay, so it's there are several blog posts that explain the behavior or how you configure it on your Linux boxes to ignore any commands that start with space on Bash, which is the default shell on most Linux systems these days. Any questions on that?
No, there was just a comment that if you don't specify the MS SQL PID, that some people aren't aware that you get developer only. There's just some feedback, not a question.
I actually meant to say that. So yes, absolutely. If you don't specify, there's another environment variable here that you would pass. Let me do this. Put this in the same line just to show you guys. We wanted to run Enterprise Edition, for example. I would pass another environment variable called MS-SQL PID. And then I would specify which version of which edition of SQL Server I want to run. If I wanted to run standard, I can pass standard here. Okay. If I wanted to, if I don't pass anything, then by default I'm running SQL Server Developer Edition. So again, that's the MS-SQL PID environment variable. So yes, indeed. Thank you for the clarification. I was meaning to mention that as well. It's important for folks to understand that the same image that you pull from the Docker repo offers all the editions of SQL Server. Just like you would select the version of SQL Server from the dropdown. If you had downloaded, Enterprise Edition from somewhere else, where you can select, different versions to install. Here, the image includes everything, so there's no switching between different images to get different editions of SQL Server. One is good for everything. That's a great comment. Okay, so do we have that container running? The way to tell is by actually looking at Docker PS. So we will run Docker PS-A, and that would tell us what it's actually running on the box. So any Docker containers that are up and running can be seen that way. So I can have multiple containers again running on this box if I wanted to. But very simply here, if I didn't have a name, I can provide a container ID. Containers IDs are always different. Okay, these are random numbers generated by Docker. Okay, basically like GUIDs. So they're not GUIDs, but they're just random hex numbers. They basically identify your container uniquely. This is why the name itself has to be unique as well. And if there's anything that you want to run within that container as well. So for example, if I wanted to see what my data directory contains within my container itself, I can say docker sudo docker exec, and then I can run an ls and say what's inside of our opt MS-SQL data, just like it would on SQL Server on Linux, right? So I actually meant to say this is the container name that you have to pass here. So docker exec container name, the command that you want to run, and then hit enter. And then that tells me what's inside of that container itself, okay? Because I'm running a list of files within that directory inside of the container SQL1, okay? So this is how simply you execute commands inside of the VM itself, all right? And so you could also do things like docker stop SQL1, and this is how quickly you stop the SQL Server container. And naturally, running it again will be just a matter of executing this command. Obviously, you will pass your own password, etc., etc. If you want to alter the password, you can definitely pass another command after the fact just to modify the password, right? So, and you can see that here in our documentation, which is pretty extensive and pretty good. You can specify, you can run SQL CMD, which is actually shipped with the container itself. So there's nothing that you have to download or install. So to execute this within the container itself. So this is how you would change your password. And remember that tip about running the command with the space at the beginning, so you don't run into any issues. So if I wanted to kick off the container itself, just like that, I run the command. Actually, that container already exists. So I can say docker run SQL1. I meant to say, we're going to remove SQL1 here. And if you wanted to kick it off again, you would do that. There we have it. We're running another container right now. So this is how quickly we get up and running, and then connecting to these containers is just a matter of using your favorite tool to do so. Right? So in this case, this is the password that I use, so I'm just going to go ahead and copy this. Then I'm going to go connect to my database engine on that IP address, which was 104.42.249.146, 102.42.249. 146. And I'm going to connect with this and there's password. Just hit connect. I should be able to connect to that. No problem. Oops, that's the wrong idea. This is 104. 104/42. That's 249. That's 146. We hit connect, and there we go. And so we got, which is just like that. We're connected to our Docker container, and this is running on my laptop, and I'm inside of the corporate network here at Microsoft. So that's how simply we got there. Anyway, so we're running a little low on time here. So let's switch quickly gears and let's talk about Windows and Mac. So again, wanted to remind you, there is no support for SQL Server containers on Windows in production. We do support SQL Server containers on Windows for developers. So development editions are absolutely supported, but not for production at all. There are plans to provide support for SQL Server containers on Windows, but we're not disclosing those right now. And what about Mac? Mac's very important as well because there's a lot of you guys using Macs out there. So if you noticed here, there's even an install guide for Mac here. So you just get your Mac set up with Docker, and then you just follow the steps to install SQL Server on top of Docker, as if you were installing it on top of a Linux box, right? It does go Docker on Mac. It doesn't run on top of a hypervisor, but it's a way for Mac developers to get up and running local instances of SQL Server in just a matter of seconds. Right? You get your Docker installed, and you get your VM install, your container going in just a very little amount of time. Anyway,
question.
Yes, go ahead, Tracy.
Yeah, SQL Server runs as the root privilege. Is there any plans to change that in the future?
We're looking into that, yes. So it does run the root privileges, but we're definitely looking into that.
I figured with you having started the security chapter, you'd be all over that.
Yes, it's a big concern for us as well. So one thing that I wanted to highlight is that we have this set of issues for MS SQL Docker. So this is github.com/Microsoft/MS SQL Docker/issues. You're welcome to check all the issues that have been open already for SQL Server on Docker and Linux, and drop us a comment there if you feel there's an issue that we're not looking at right now. So for example, you see support for SA password file for Docker Swarm, login fail for SA. So any particular issues that you may be running into, we're pretty good at staying on top of all the issues that people are mentioning here. Okay. So we have run out of time, but please do stay in touch, guys. If you have any questions, feel free to ping me on Twitter. My handle is Argenis. You're also welcome to shoot me an email. My email is argenis.fernandez@microsoft.com. And again, thanks for your time. I apologize for not being able to answer 100% of your questions, but I will definitely, if you're particularly interested in getting answers to any questions immediately, shoot me an email. I will try to get those as soon as possible. And then I'll see about making a little addendum to the presentation so I answer any questions on the PPT itself to be provided to the organizers of these clinics. So thanks very much for your time today, guys.
All right. Thank you for your time, Argenis.